Okay, I think we're ready to kick off. So I'd like to start by acknowledging the traditional owners of the land on which we're meeting today. In my case, that's the Wurundjeri people of the Kulin Nation. I'd also like to acknowledge traditional owners, any elders joining us, any elders both emerging and current, and acknowledging Aboriginal and Torres Strait Islander people joining us on the call today. Welcome to today's expert webinar on digitalisation and energy management systems. This webinar is being run by the Energy Efficiency Council, from where I'm coming to you from as the head of policy at the EEC. It's being run on behalf of the Australian government, who participates in something called the Energy in Buildings and Communities Technology Collaboration Program. It's a bit of a mouthful, but that's essentially an international research collaboration that was established under the auspices of the International Energy Agency to advance our thinking on ways that we can improve energy use in buildings. It was established several decades ago, and today is one of the more active technology collaboration programs in the IEA. Australia participates very actively in that technology collaboration program, and there's a whole bunch of really interesting research going on that a lot of Australian researchers are involved in. We have, there are, I think at last count, we're getting up to about 90-something projects that are taking place under this collaboration. I think it's 96, maybe. Stephen can probably confirm that. Thank you, Stephen. And there's a lot of research that goes on there that it's important, makes its way back into the community. So all of that expert knowledge is communicated back to the Australian research community and also to policymakers here. So that's what a webinar like this is about today. We're going to hear from Stephen White, who is involved in several of the work programs that take place under the research collaboration. They're called annexes. So you'll hear a bit from Stephen later on the webinar around some of the research taking place internationally that he's involved in. But before we do that, we've brought together some speakers from industry, and they're both members of the Energy Efficiency Council, to tell you a little bit about the technology solutions that can empower Australia to use digitalisation to improve the energy performance of our building stock. And we're very lucky to have Ian Harding as our first speaker from ABB Australia. So he is a product manager there, and he oversees the development and implementation of cutting-edge solutions for smart building controls automation. And he's spent a lot of time working on lighting and other systems automation in commercial buildings in particular. So he's going to have a lot to tell us about ABB's work in that sector. Before Ian kicks off, though, I should mention a couple of housekeeping things. If you have questions, can you put them in the Q&A section of Zoom? And we'll be monitoring the Q&A section, and we'll come back to your questions at the end. The idea is we're going to hear from our three presenters, and then we'll have a time for Q&A at the end. So put your questions in the Q&A, and we'll keep an eye on that. And then we'll have an opportunity to go through those questions at the end. I think that's probably all that matters in terms of housekeeping. With that, I'd like to introduce Ian. So Ian, the floor is yours. I think you've got some slides to put up on the screen too.
I do indeed. Thank you very much, Jeremy. That should be sharing now. Everybody should be able to see. Yes. Hopefully we can see everything. It's only an 82 slide deck, so I think we can get through it in about the next 3 hours. But sorry, I spend a lot of time talking about building smart buildings, and I have years and years of work in this area. So I'm from ABB. For those of you that have never heard of me and don't know me, there's a quick introduction. You can get my contact card here. It's really easy. We tend not to print business cards anymore because we're sustainable. So we use QR codes. But if anybody needs me, or anybody needs me to get in contact with other people in the business, please let me know, because we're a big organization and it can be very, very hard to find people within a big organization. I know it too well. So if we think of ABB and what we do in the smart building area, well, we have a huge portfolio of products that go into buildings throughout the world. We look at KNX, we look at Cylon, we look at all the digitization of all the products we have. And the idea is that we connect all these components together to sort of improve the optimization of the building and really to satisfy the people in the building. We remember back in the 80s, we had things like sick building syndrome and things like that. The idea now is we make smart buildings and digital buildings that are better for people to work and live in. And not only do we use our components, sorry, I'm just changing slides. Sorry, not only do we use our components to improve buildings and building life, but the idea, of course, is to make it as sustainable as possible. And that's a huge drive within ABB at the moment, where all of our factories are on what we call M2Z, or mission to zero, where they're all heading towards zero carbon emissions and zero, they're reducing garbage and rubbish. They recycle absolutely everything they have now. And even our warehouse now here in Sydney now recycles all the cardboard boxes it receives, uses them and sends them back out to people. So from years ago, where we used to throw everything in the bin and everything was thrown to trash, now we recycle everything, and it's all very sustainable. But I could talk for hours about this, but really what we're talking about now is digitalization and how we have digitalized buildings over the last 10, 15 years and what we have come from and where we're heading to. And the idea was we had conventional systems many years ago. They were hardwired. The electricians had what I always call a rat's nest of connections, a million cables connecting a million things, and nobody really knew what was happening. Nowadays, everything is seamlessly integrated and connected together. And it's usually the data is collected on a head-end control and supervision computer somewhere that's going to give us all the data to deliver the solutions. And if we look at a range of suites nowadays, we have a huge range of products. And these products will enable you to control every part of your building. You can see the bottom layer across that I have here is on the left-hand side, we have our KNX, which is mainly used in Australia to control our lighting. We have Modbus communications with all our switch gear. We have BACnet and Cylon control giving us all the data about HVAC through the building. And then we can pull other information from everything and anything else we can connect, from the lift, from the fire system, etc., etc. But all that data then can connect back onto an IP network, and we feed it up to what we call an edge control system. And the edge control system really is the interface between the building and the internet. And this collects the data, collates the data, and then fires it up to the cloud. And from the cloud, then you can see we have sustainability with Building Analyzer. We have sustainability with BrainBox AI. And we have web services and all sorts of stuff. See, you can manage and see your building from anywhere. But the really exciting one nowadays is the BrainBox AI, because what that is now doing is looking at predictive energy usage in buildings, looking at room utilization in buildings, and trying to take that data and sustainably use the energy as best we can to maintain the building the best way for people as people move around the building. And as this develops more and more, we are learning more and more and better how to improve the performance of buildings. We all look at sort of improving the insulation, putting double glazed windows in and all that, but a huge part of building energy management now is actually how we manage the energy that we have to use and what we actually do with it. And digitalization allows us to take all this information into the cloud and create useful information that gives us better decisions to make about how we use the building and what we do there. If I was to look at sort of projects throughout Australia, there's many projects we have done. We do a lot of, as Jeremy said, we do a lot of projects in commercial buildings, skyscrapers around the cities. And one of my pet hates, of course, is to walk through any of our cities and see lights on through a building all night long. And everybody just leaves lights on, and we're wasting so much energy. It's not good. But the ANZ Tower in Sydney, we managed this many years ago. And first of all, of course, we put in our KNX lighting control systems throughout the building. Then we put in solar shading, and everyone thinks of solar shading as great, And the more you think of things like solar shading, the more you understand, because not only do we reduce energy in the building, through heating and cooling, but we make the building more comfortable for people by reducing glare and all that sort of stuff. And of course, then we've interfaced with security, air conditioning, PV. Everything you can think of in that building is all talking to each other. They're providing a digital solution for the building owners to maintain the building as best they can. And that's just one of many examples. Another great example was the Monash University New Horizons building, where we started off with, well, what do you want to do, guys? And they didn't know. So we had to bring them down the path of, here's what we can do. So we ended up putting in constant light control systems throughout the whole building, whereby when the sun is shining, the lights dim themselves to off. When the sun goes behind a cloud or when it gets dark in the evening, the lights will then gradually come back on to replace the lost light from the sun and maintain a constant lux level. And the idea behind this is we can take that information, see how energy is used in the building. We can look actually at how people move around the building as well. And think of in previous generations, we couldn't process all that data. Now we can take all that data and make much better use of the data. We can make much better informed we can make much better informed decisions about how we manage our buildings. That's really just a quick, brief overview of what we can do in the building space. I could talk for hours and hours about this. If anybody needs more information, just talk to Jeremy. You can always get in contact with me. But the thing is, we can digitalize everything nowadays. We have AI now coming into the suite of products that we have that can help us enhance our buildings and make them better for people to live in. Thank you very much for listening to me. Back to you, Jeremy.
Thank you very much, Ian, and thanks for giving us a little taster of the sort of technologies we're talking about when we say, digitalization and energy management systems. That slide where you kind of show the different layers of technologies involved really helps elucidate it for us, I think. Looking forward to talking more in the Q&A session. If people have questions about the actual technology suite and how it all works, I'm sure you'll be able to answer those sort of questions. I'd now like to go to our second speaker. Now, some of you may have seen the initial program for our webinar had a speaker coming to us from IEA HQ in Paris. Unfortunately, that person has fallen ill and isn't able to join us today. But I'm very glad to announce or introduce Sarah Harvey, a senior consultant from Arup, is another EEC member. And Sarah works closely with the regional and global teams in Arup to deliver decarbonisation services. And in the last 10 years, her experience is focused on sustainability strategy development and implementation for property developments and other assets, and has worked on some of the major rail projects in Australia and the UK as well. She has a wealth of experience. I'd like to thank her for stepping in at the last minute to present some work that Arup has done in this space. And take it away, Sarah. Thanks for getting us slides for it.
Thanks a lot, Jeremy. Can you see my screen?
We can.
Great. So good afternoon, everyone. Thanks for that introduction and the opportunity to join this session. So as Jeremy mentioned, I'm a senior consultant at Arup, and Arup is a global sustainable development consultancy, and we do a bit of everything and anything. So today I'll briefly touch on a research project that's being undertaken at Arup that's very relevant to this topic. I can't claim any credit for that one, but I can put you in touch with the right people if need be. And then I'm going to talk through a case study for a real life project and our process for identifying opportunities to decarbonise portfolios of existing buildings, utilising the energy data to support effective decision making with clients, and highlight some of the challenges and opportunities faced along the way that this area would be a great benefit as this area progresses to kind of develop in that space. So, as we all know, buildings currently operate independently and are driven by demand. But in the future, buildings will be hopefully optimized by AI to become more responsive to electricity supply. So despite the availability of some AI control vendors in the market, the uptake of this technology in the industry has been limited to date. So the aim of this research project that's ongoing is to bridge that gap between academia and industry and build a bit more trust in those AI control systems, hopefully leading to wider adoption. So this project is exploring a new process for evaluating advanced control systems and their impact on electricity grids by converting buildings into virtual batteries, which that graphic is showing there. So any questions on that, let me know, and I can also direct you to people who would know a lot more about it. So stepping from research that's aiming to bridge the gap between academia and industry, jumping into a case study for an actual project. So this is an example of a process that we've used to identify and digitally present opportunities to decarbonise. So the question that was posed to us in a simplified manner: how much will it cost us to electrify our portfolio of existing buildings? The client was wanting to understand the implications of transitioning towards all electric with growing industry shifts, and of course follow-on questions that needed to be answered and adequately considered there around how much energy and operational costs could be saved through other energy efficiency measures that weren't currently being captured. How would that impact electrical load and existing infrastructure, and when should they act? So what information did we have? We had access to an online energy data platform for all their sites, which was great, but it was a real mix of what information was available: interval data for electricity, some gas interval data, otherwise bills, some manual reads of submeters where they were available to help us understand the split of energy consumption. We had some asset registers varying in quality and completeness. As many people would know, it's a real challenge in keeping that up to date. Access to sites and building operators, and access to their BMS, but only on site. We couldn't get access to it remotely, which was a challenge. So what did we do? We did site level assessments. Just on the right is a kind of graphic of key things that we were working through and looking at on site. We established a short list of typical systems and corresponding replacement opportunities. In this case, we were focused on electrification in the immediate term. And we established key metrics to be applied. So energy conversion, looking at how efficient their systems were now, what the new efficiency would be with the proposed solutions, and working through what that capital expenditure could be, and working back to use a variety of inputs from other projects and industry to kind of build down a dollar per kilowatt figure for these works to be able to apply it in bulk across our portfolio. So then, so we had a lot of variables, we had a lot of initiatives, we had a lot of sites, so we needed an interactive way to be able to present the options and opportunities to clients. So I need to credit my colleague Sheldon Walters, who did all the development here for this dashboard and similar ones. So we were able to apply these established rules around change in energy consumption and estimated capital expenditure when an initiative was selected in any given year. And then that was really important to the client being able to control when and where kind of initiatives were happening. So we built up this dashboard so that you could see live that impact of kind of where those changes would happen. And so we have predefined pathways here. This example is looking at electrification like for like, so swapping in the same size equipment but an electric version. The ultimate goal in this scenario was to be 100% electric by the end of their period, but we also really needed to use this opportunity to communicate the impact of other energy efficiency initiatives and how significant they could be, and the magnitude of comparison to electrification. So just jumping between, so we'll see here, electrification only, and then electrification, bringing in other measures that they weren't currently doing and optimizing performance as much as they could to really communicate the value and the benefit of that. Picking up all that kind of low-hanging fruit that these clever systems can provide. And so we were able to have preset user displays, but then client can come in and change and move things around and see how that impacts the overall trajectory. This here is displaying our energy split at a starting point and then where we're kind of ending up, but we also displayed what that impact was for cost over the period. So in this display, we're showing cumulative energy costs in the kind of business as usual case, do nothing scenario, and then we're showing our projected energy costs in a just electrify case. And as you can see, they're pretty much no change. So it's a hard sell to push through with electrification in that case. We use the dashboard to really wrap in the benefit of not doing electrification early, but bringing in all these other opportunities to make it a more kind of viable pathway. One key factor that was a big variable was energy prices. So we built in a toggle so that that wasn't a hold up in conversations, so that the client has the flexibility to change projected gas and electricity prices and see how that impacts their trajectory. So that's a very quick spiel on the process. But just to kind of come back and wrap up on some key takeaways to tie it back to digitalisation and energy management systems for existing buildings. So I guess, you know, there are these amazing systems and processes out there, and highlighting the gap between kind of where we are for some existing buildings and where we kind of need to be and how to get there. So some key challenges and opportunities, engagement at the asset level with tools and data. So I've seen this on a number of existing building projects, and it happens all over the place, where there's some great tools and systems set up, but they might not be being used or optimized to their maximum potential. Asset readiness is a challenge, so careful consideration needs to be had for any in any upgrade works to ensure that advanced control systems can be incorporated to future-proof assets as we're going through these system upgrades. Privacy and control is a great kind of barrier or client concern that we're seeing. And of course, for us, it's always important to consider what's important to the building operator, whether that's cost, whether that in this instance, they're very customer centric, so really experience focused and really apprehensive about changing set points or kind of not wanting to make sure that the occupant was as comfortable as possible. A huge opportunity, I think, in this space is around clear targets and ambition. So an obvious one is neighbours, and what gets measured gets managed. So a true success in terms of energy performance improvements. So I'm a firm believer that any kind of ambitious targets or requirements that can be set for industry will only support innovation in this space and drive uptake. And a big one is accountability. Who's doing what, championing that system, and ownership on those targets and ambitions. So just to loop everything back together, this was a kind of example of our process focused on electrification. And I guess as we're seeing more and more clients focusing in this space and needing to progress towards that shift, we need even more focus on this area to carefully manage demand, because our reliance on these energy management systems is only going to grow exponentially as we've got more and more electricity consumption happening. So sorry, that was a bit of a wild whip around, but I'll hand back to Jeremy.
Thank you, Sarah. Thank you for the whip around, and we will come back to some of the things you raised in that last slide of the Q&A. Interested to probe a little further. But before that, I would like to introduce our final speaker before the Q&A session, and that is Stephen White. And Stephen is our representative from the Energy in Buildings and Communities collaboration program I talked about at the beginning. He also leads energy performance research at the CSIRO. He has over 25 years of experience in energy, end-use efficiency, and electricity and demand-side management. So his role in this collaboration is that he's the operating agent for one of the research annexes, as they're called, Annex 81, which is titled Data-Driven Smart Buildings. And he's also going to be involved in a new bit of research that's coming up under the EBC collaboration, which is Annex 96, I believe is the right number. I'll leave it to Stephen to explain what all that's about. And because Annex 81 has finished, Stephen is able to give us a bit of a rundown on what that research is showing. So hand it over to you now, Stephen.
Great, thanks so much, Jeremy. You can see my slides. Yep, cool. Yes, so I've been running Annex 81 over the last 4 years. There's a whole world of research there. In the available time, I can't really talk to all of it, but it's certainly a fun ride working with 19 countries and over 50 organisations investigating this topic of data-driven smart buildings. So just focusing in on just a small part of it there and putting out a provocative sort of start here, and that is that our schemes and policies, whether it's neighbours, our certificate schemes, whether it's our National Construction Code, not only should it be considering annual consumption of energy, but also the time of use. And the time of use is just going to be so much more important over time. And here's a nice little plot that sort of explains that pretty well. So this is an example from of the energy supply mix in South Australia in spring last year, showing where the electricity is coming from midnight to midnight. Shows the type, so the yellow blobs there in the middle of the day are solar energy, the green is wind, and it also, just in the bottom right there, shows the price over a 3-day period that those resources were getting. And what does that actually say to you? You know, as our electricity grid becomes more and more like that, it looks like we're going to have a heck of a lot of free, zero emissions energy in the middle of the day. And by contrast, we're going to have expensive fossil fuel energy on the shoulder periods and at night. And not only was it free zero emissions energy, in fact, over those 3 days, you can see it was actually negative. That is, people had to, the electricity energy supplier had to get paid, had to pay to get rid of their energy. And so essentially what we're needing on the demand side is people to start to think about shifting their energy demand to that time when they can get low cost energy that is zero emissions. So load shifting or time of use is becoming incredibly important. And the question then is, how do we do that? I would say that digitalisation is a key enabler for us to be able to do that in buildings. And by digitalisation, sort of talking to what Ian was saying, kind of three key components of it. One is access to data to give us situational awareness of what's going on. When is there free, low-cost energy from renewables? Another part of it is the connectivity, that is the ability to share information between the energy system and the buildings that are consuming energy. And the third part being the analytics, or the brain that drives the optimization. So my colleagues at Lawrence Berkeley National Labs created this particular diagram, and it just shows that digitalization story. We've got all these different data sources that all need to be brought into a common data warehouse environment. And that is, if you like, the digitalization infrastructure. Lawrence Berkeley National Labs likes to use the term EMIS, Energy Management Information System. So it's not just metering, it's a system around that so that you can manage what you measure. Once you have your data collected and warehoused, you can then use that data for doing all sorts of useful energy productivity applications. Energy bill monitoring, energy analytics, equipment fault detection and diagnosis. I would say that we're relatively good at that in Australia, particularly in our CBD buildings. We've got the neighbours program, so collecting data for neighbours and converting that into a rating and creating transparency is kind of part of that digitalisation piece. But then when you get to something like equipment fault detection and diagnostics, Australia has been leading the world in with companies developing that technology, and we've deployed it quite substantially. Once we get to building controls optimization in a more dynamic kind of a way, perhaps we're relatively immature there and even less mature when it comes to flexibility. Flexibility being that piece of the equation where we want to start shifting our demand to the time when it is cheapest and lowest emissions. If Ksenia had been on the call, she would have probably used exactly this diagram, because I've taken it from her, just from the IEA's net zero emissions by 2050 scenario. We need to have a 10 times increase in the amount of flexibility that we get out of buildings there. So there's a big requirement to incorporate flexible demand into our built environment. So what we did in Annex 81 is we brought together all the information on the barriers to digitalisation as enabler for this clean energy transition and the solutions for increasing adoption. And we did a whole range of interviews around the world with different experts, interestingly, with Brainbox AI, which Ian mentioned was one expert there. And we've presented what we consider the plan on the page in the annex in the same format as the IEA has for its policy packages. That is, there is a set of targets. So right now, the immediate opportunity for doing this is that this is a no regrets thing to encourage, because it cost effectively can deliver savings of up to 40% in in some cases. But as we go forward to 2030 and 2050, we're starting to see in the IEA's net zero scenario that, first of all, we bring in new buildings that should be digitally enabled or have the connectivity to be able to automate electricity demand flexibility. And then by 2050, our existing buildings are adopting this as well. So that's the targets part. And then we have the solutions there, and we identified 8 themes for solutions that would help to increase adoption. We categorized the themes and the subcomponents of them by the standard IEA methodology. That is, what can we do in regulation? What can we do in information provision? And what sort of incentives we can do. Obviously, we can't go into the detail of all that text, but just to run through the 8 themes. Theme number 1 was around providing information, because we identified in all of our stakeholder consultation there that complexity was a key barrier for digitalisation and information asymmetry between buyers and sellers. So could we help with that? We think there's need for more information in the industry. And interestingly enough, there was a lot of kind of the most visceral response was around data and data sharing risk, and how do we simplify data sharing to take away that risk and to use and to do it in a way that actually informs the industry. And there was strong support for an idea of certification around a concept of digital ready as a way of enabling the transition. There was also a need, again, sort of comes perhaps back to information there, to be able to get lots more case studies and evidence of people actually doing this and benefiting from it. So there was a feeling that government should put its money where its mouth is, so to speak, and to adopt digitalisation as part of its net zero strategy, and to harness the stories and narratives that come out of that by harnessing the research industry to validate and tell the stories of successful examples. As far as the money is concerned, the feeling that I got there was, sorry, but buildings currently don't have good access to the financial flows in the electricity system in a fair and level playing field way. So there was a desire to better integrate buildings into the electricity system. And yeah, no one was going to say no to some incentives, but in fact, theme 5, incentivize, that's throw money at EMIS technology, came out probably the lowest in terms of importance there, because there was a general feeling that if there was a level playing field, this was the lowest cost way of providing dispatchability into the electricity system. And then the final one was building workforce skills and capacity so that we could deliver this at scale. And we think that digitalisation in itself is a key part of creating that capacity, as digitalisation is a core tool for automation and for communicating how to fix things up. So those were our themes. Happy to take questions on that. Pass back to you, Jeremy.
Thank you very much, Stephen. Okay, I think that's enough stimulus material to get us started with a bit of a conversation now. And again, I'd just like to encourage the audience to place questions in the Q&A function of Zoom. But I would like to start by asking some questions, because I was sitting here thinking, as you started, Stephen, around sort of the need for digital grid-connected buildings to participate in the electricity market, as that, you showed that slide at the very beginning of the increasing penetration of renewables, and the fact that in the middle of the day, we've got this renewable resource, and in the shorter periods in the evening and morning, it's not like that at all. And today, obviously, the system operator in the eastern states, AEMO, released its updated ISP for 2024. In the ISP, it talks about the need for consumer energy resources and also demand side participation. There's two sort of, if you look at the charts there of the different bits of capacity that they project needs to happen under the step change scenario, there's this sort of orchestrated consumer energy resources that includes everything from batteries to EVs, but also some of this flexible demand stuff. And then, so what I guess what I was thinking about as I saw your slide, and you also mentioned at the end there, incentives weren't necessarily the biggest priority, because actually it's cost effective. It's the most cost effective sort of dispatchable capacity that we should add to the grid. My question is, if it's cost effective, if it is such a good option, what are some of the barriers that are stopping us from doing more of it?
Yes, so we delved into the barriers, and I could speak for a long time on that. Interestingly, one of the issues that sort of came up was there was actually despite the fact that there are these large programs such as the Energy Analytics Campaign in the States and stuff, where we have kind of proven, if you like, the cost effectiveness when it comes to the perception in some of our interviews was that it was actually quite expensive. And I think when we drilled down into that, it was corralled into the digital infrastructure piece rather than the deployment of the energy service itself. If your building was digitally ready, because you were doing it for a whole range of different purposes, and your new building, and you had your fiber backbone and all that. So if you had all that kind of at inception, the actual incremental cost was incredibly low. But if you were kind of coming at this as a retrofit, and you are trying to seek out a solution, a bespoke solution for the digital infrastructure in a world of many different offers, many different services and stuff, the complexity almost stops you from getting started, and hence this sort of need for some level of standardization or certification, or some way where people actually know what it is that they're buying, I think. I don't know whether that resonates for you, Ian. I see some nods. You're at the cold face more than me.
It certainly is, and you often get those questions from people. What is it? How does it work? And to try and explain, and then you get into the nitty gritty of how something works and how it's going to save the money. And the first thing I always come against is, what's the payback? The payback period because you're right, in retrofitting a lot of these buildings, it's a highly expensive piece of work for people to do. And it becomes an OPEX versus CAPEX battle a lot of the time. So yeah, I totally agree it is. And for people, we have all these manufacturers, we have all these products, we have all these different people, and the old saying, beware of people selling snake oil sort of thing, you know. Some are good, some are bad, but how does an end user in a building know what they're getting? How do they know that they spend X, is it going to give them the payback of Y that they were promised? And I think certification is a very good way to go down that, because then you're going to have a suite of products that us as manufacturers can now propose to people and say, look, we have this certified, it's certified by this team of people, and they are going to be your guaranteed payback. So your investment will give you what you want.
That's partly the way the industry works around in a very siloed kind of a way there. If I want to sort of pin a retrofit against one particular smart building application, it's going to be a tricky ROI. But if I'm enabling my building for a whole range of things, and if I'm doing a head-end upgrade on the BMS, you know, the incremental cost of actually getting this piece of extra functionality is peanuts.
Absolutely. Yeah.
Sarah, I wondered if you might be able to weigh in here on this idea of the making the case when you're talking about retrofitting buildings, because I think what jumped out at me from your presentation was that you were using a kind of digital tool in order to make the business case for the client as well. You know, you had some data that you put into this tool to show them scenarios, and so digitalization itself was important for even making the case in this instance.
Definitely. And it's still a very, in the retrofit space, it's an incredibly hard sell, and only wrapping it in with, especially for that electrification piece, it's incredibly expensive. So you can't do it in isolation. It needs to be really carefully considered and wrapped into their existing maintenance and refurbishment cycles to really maximize any benefit and any opportunity that can be capitalized on, and make sure you don't miss those opportunities to kind of make those necessary upgrades and future-proof you for these other systems. Otherwise, you're in trouble from a cost perspective.
Just on the idea of recouping some of those costs, you know, at the EEC we advocate quite strongly for policies that reward people for bidding into wholesale demand response markets, or creating building capacity that might even be just potentially bidding in, and that's part of the CIS, the Capacity Investment Scheme the federal government set up. You know, we advocate very strongly that demand flexibility should be prioritized in schemes like the CIS, not just, you know, concrete and hard infrastructure that you can see being, you know, like a wind turbine or a solar farm. To what extent, I don't know if the panel has any views on this, in terms of making the case to your clients in the built environment, what extent do you think it's important that there are policies like the wholesale demand response mechanism, or in New South Wales there's the peak demand reduction scheme that also rewards consumers for, you know, allowing their resources to be used in virtual power plants? Is that increasingly an important part of supporting the deployment of digital building and grid connected buildings?
I'm happy to wade in on this particular one. Yeah, I would say that all those kind of mechanisms in the electricity industry are geared around a particular perspective on what the solution's meant to be. You know, wholesale energy is based around power stations bidding to dispatch, network, financial arrangements are all based on the assumption that, you know, it's about taking up transformers and poles and wires and things. So these are complex things, and some of our stakeholder work said that the consumers said, well, why would I participate in this when in a bidding type thing, I don't even know what I'm going to get up front. So they just need such more certainty around what the reward schemes are if they're not major players in the industry. We had feed-in tariffs for solar PV, and the industry was able to develop on a very kind of well and easily understood sort of reward for action type thing. So I see things like the certificate schemes and things like the wholesale demand response mechanism. Wholesale demand response mechanism probably less so in the sense for a whole bunch of reasons which I could go into, but as a way of actually saying, well, the electricity industry will do this, but we need something simple for customers to be able to respond to, and that's a way of bringing the two sides of the market together, so we end up with a two-sided market of some description.
Thanks, Stephen. Before we move off the discussion of sort of retrofits versus new buildings, Ian, in the lead up to this webinar, we were having a bit of chat around the practical realities when it comes even to new builds, forgetting retrofits and the challenges that are associated with retrofits. I remember you told me some stories around the practical realities of when you do a nice plan that says we're going to put all of this infrastructure, this digital infrastructure into the building. When it comes to actually building the thing, there can be a breakdown of communications or, whatever, for whatever reason, the infrastructure that you planned doesn't get built. Can you maybe tell that story publicly to this group and a bit about what you mean by these sort of the challenges of even doing new builds?
I think I can say from my perspective, we often see projects being designed and they come up with everything's going in, but then cost comes into it, and then the builder gets the project, and the builder will meet the minimum specifications available because the builder wants to make some money. Times are tight, and he has a lot of cost increase and cost pressure throughout the building. Very often, I feel that the building that was designed is often not the building that's delivered, and technology very often is the first thing to get cut. Certainly from my side, because I'm usually the last person into the building. We have the groundworks and all the building and the construction, the physical construction of the building. So by the time we're getting to the end of the construction, the builder could be running out of money and there could be a lot of stuff gone. And that creates a huge pressure then on cost cutting in areas that we know we can save money. So it's a CapEx again versus OpEx. They're trying to keep the CapEx under control, and that will be their sole focus. And they won't look at the OpEx of the building. And I do remember I saw this design and construct coming out in the UK many, many years ago. And that's what was happening. A lot of the technology was getting stripped out of the building because the builders decided we can do an equivalent and we'll save money by doing an equivalent. And yes, it works, but maybe it's not as perfect as you wanted it. So to get around that, then it was brought in, and a lot of the projects went to design, build, and maintain for 10 years. And suddenly guys had to think about the OpEx and how is the building going to work and how can I save money on the long-term working? And back to what we've all said is that, you will see the energy efficiency and the savings and all that come out of a building over a number of years where you may not see it at the start. And I think we have to head that way. Maybe sort of, we're not just looking at building a building and the builder builds it, rubs his hands and walks away with his money in his back pocket. I think the building life is usually about 20, 25 years. So we have to have some sort of, what is the energy efficiency and what is there has to be a tie-in to say we have to design, build and maintain for 10 years. Something like that would be my idea.
Yeah, that makes sense. Kind of changing the incentive structure for the builders themselves so they're not just sort of set and forget. They actually have some sort of skin in the game for the long-term viability of it. And then that would make sure that things like the digital infrastructure actually goes in as was planned.
Exactly.
Anyone else want to weigh in on that one before we go to an audience question?
I think just, reiterating what Ian said, I think I definitely saw it working on metro projects where it was, the asset operator was in the room for design meetings, and it really changed a lot of the outcomes in those conversations. So it was really great to see that, and I think that idea is a brilliant one.
Thank you, Sarah. Okay, we have a question in the Q&A, which is, how do we most effectively promote digitalisation to smaller businesses, / those with low profit margins? who tend to prioritize day-to-day operations. So this is kind of a similar question to the one we've been talking about to some extent, but really focused on those smaller businesses. It's a good question. You know, the sort of solutions we've been hearing about today and the sort of solutions that ABB and Arup are working on, would it be fair to say your clients are generally fairly big companies in big, you know, commercial buildings? Or do you also have a sort of client base that's more in that SME space as well? And I suppose maybe this is also for Stephen, you know, how talk about market maturity in one of your slides. Are we there yet that that the SME sector can kind of benefit from some of these things that are coming into play? And indeed households as well, if anyone wants to talk about households.
So the Victorian Energy Upgrade Scheme put out a consultation, and we've done a little bit more consultation work, which was to actually provide certificates for energy management information systems, which is the sort of technology we're talking about there. And because right at the moment, the way the schemes are done, it would be quite difficult to get a kind of a rebate through the certificate schemes for an EMIS technology, because you can't sort of predetermine how much savings you're going to get. That's always been one of the issues with energy efficiency in general. You know, you don't know what you're going to save until you actually start measuring and start implementing stuff. But using metered baseline methodology and streamlined digitalized tools, we believe we could substantially reduce the cost of measurement and verification, and do performance-based returns there. And you know, we've had for a long time, we've had the certificate schemes reaching out to residential customers with very small loads, and being able to provide products quite cost effectively when the incentive is right. And you know, crunching through the numbers, we'd be pretty confident that that would be a goer.
Thanks, Stephen. Anyone else want to weigh in on the question of the smaller business segment of the market and the potential for these technologies to service them?
When I'd look at the smaller sector, say you walk into a business park, you'll have multiple business units together. I think we're talking about that, maybe that size. I'd see maybe, you know, we talk about in some remote areas of having group power systems and group sort of solar and all that sort of stuff, community based. And I think that's what we need to do in an area like that, where if we have a group of 10 or 12 small enterprises, well, let's gather the data from the whole lot of them and show them together how, when they operate together, it can save energy for them, and it'll add to their bottom line, which is really what they're struggling with. And we know how the businesses are at the moment. They need money, they need cash. And if we can show them, well, you're going to spend less on your electricity, I think that is going to be a great thing for these guys.
I'd also point out the automation aspects of digitalization. You know, we can have individually addressable devices and stuff using modern digital technologies at really, really, really low cost now. And I think what we're, from a sort of a behavioral point of view, for small customers, what we need is the scenario where they make a decision, an investment decision on something, or accept an offer from a utility or what have you, but then it is automated from then on. And that way it all becomes very cost effective. I note that Energex and Ergon have recruited demand response enabled air conditioners at a price of around $200 per kVA, which $250 per kVA, which is around 20% of the cost of batteries. So, you know, you can do this at scale for small customers very cost effectively.
Certainly, that's a great thing. I mean, I look at today, my sun is shining all day. I run the dishwasher during the day. I have the split system on heating the house all day, and I use that electricity rather than export it. But I have one of my colleagues has just taken it down to the domestic level. One of my colleagues has put an automation system into his house. He's up in Queensland, and what does he do? The sun shines during the day. He heats his pool. So while he has plenty of electricity, the pool automatically comes on and starts heating itself. He's an EV, so when the solar level gets to a certain value during the day, he'll start charging his car. And it's all automated. And I think you're right, it has to be automated, because by nature we get lazy, we get forgetful, we get into routines, we get distracted. We have to automate it.
There's also some good
go ahead, Sarah. No, go.
tech coming out just in terms of thinking about residential space and apartment blocks, and if you don't have your own roof space around software systems and that can collect obviously renewable electricity, but then the way that they divvy it up amongst sort of behind the meter to users is equitable and even. So it's some great systems coming out to be able to reap those benefits that traditionally have been had extra barriers because it's not your own roof or it's not your own space. So we're getting there slowly.
That's perfect. There's another question from the audience. We've got a few minutes left, so I'll just ask this one now. And the question is around whether AI is the most suitable tool for managing a building's energy needs when a less sophisticated and far less power-hungry algorithm could be adequate. And I think this is pointing to the fact that, you know, with AI, you need data centers that are very energy hungry to produce the results. It's been a big topic in the news recently. Are there simpler algorithms that aren't relying on huge AI models to make decisions around energy that could be more effectively used, or is AI just going to happen anyway and we should use it for this purpose? I'm interested in the panel's views.
So if power hungry is large language models, then yes, love to do research on large language models. Do I see them as being operating in real time? No, for this kind of application. I guess digitalization, as I said, the three aspects of it is the sensing, the data and situational awareness. Another one is connectivity, and the third is the brains part of it. You know, the ability to throw sophisticated algorithms at it. We will need connectivity as a bare minimum for this kind of thing. How else can you get the information of carbon intensity of the grid and price and things interacting with consumer loads? So certainly connectivity is part of the digitalization. Do we need wildly sophisticated? You know, does a sophisticated algorithm in various things, is it kind of perfect, or is a timer clock you know, kind of getting you 50% of the way there? That's a good question to ask, how much of the smarts we need to apply to it. But one of the things, sorry, when it came to rebounds effects, you know, you've kind of done all this sort of controlling of stuff. One of the worst things, and there's a long history on this with hot water systems, when they come back online after being switched off, there's a big demand spike that comes back. So again, that sort of connectivity, so that we've kind of got some level of fleet level orchestration is important.
Thank you, Stephen. And yeah, I think you were touching on this in your answer, the idea of might be horses for courses, where for some applications, AI might be very appropriate. One thing that came to mind when you were talking about that for me was I had a conversation with Google in a previous role, who were using their AI to identify the best way of coordinating their data centers across the world so that they would be coordinated at times of renewable energy generation, so that they could guarantee 24/7 renewable energy use across their data center fleet, not just, you know, setting up PPAs to purchase and develop renewable projects, but actually saying, no, we can guarantee that at this moment of the day, you are using renewables. And that was because of AI that they were able to do that. Their algorithm was finding all the opportunities to, you know, turn on this data center over here at this time of day when new demand is going to be highest because of the weather, or, you know, whatever else was going on in that country. People would be Googling certain things, so they knew that it was time to turn on the data center in that part of the world, which I thought was pretty interesting. But yes, you're right. So the questioner, I was probably thinking about, you know, on a smaller business, for example, yeah, it can be quite simple. The digital solution doesn't necessarily need to use that. Let's, realizing it's 5 p.m., people want to end their days. I would like to probably wrap it up at this point and thank our three panelists, Stephen, Ian, and Sarah, for their time. And thank you, the audience, for joining us and for posing the questions you did. We will be holding more webinars on behalf of the EBC, IEA EBC, and the Australian government as well as other webinars that the Energy Efficiency Council just runs separate from this project. So if you haven't already, head over to eec.org.au and sign up to our newsletter so you can hear about what's coming up next. Thanks again, and have a good evening, everyone.